this video I'll see what is degree of freedom and how many degrees of freedom does the robot has got. So here a robot has got 6 degrees of freedom, that is the vertical traverse where it is going to happen. Another one is the rotational traverse. Rotational traverse it will be there. Here also it is there. Radial traverse is there. And 3 axes of motion with respect to the wrist, that is pitching, yawing and rolling.
Hi everyone. In this video, we discuss about degree of freedoms in robot. So here I have drawn the sketch of polar type of robot. It has 6 degree of freedom, and out of 6, 3 motions are of arm and body motions, and remaining 3 are wrist motions. Here, as you can see in the sketch, here is a body, and this is the arm. Here is a wrist, and here is an end effector at the end. So first 3 motions are of arm and body motions. In that, first is vertical traverse motion, which provides up and down movement to arm with the help of these linkages. Second is rotation traverse motion. It provides rotation to body about vertical.
So further, if you go with if you take other robot, here you can see rotational, traverse and radial axis which is present. So all the robots it will be present, which it keeps on going. So here when you want to define a robot, here you can see that vertical axis rotation it is present on the base. So rotational traverse it is going to happen with respect to the vertical line what is shown the red line. So radial traverse happens, which is indicated in the red line. So further, if we take the part is folded over here, for this there be pitching, yaw and roll it will be there. So here this is with respect to end effector. For the different robot it is defined here clearly. So here stage by stage every motions it is defined clearly, and according to that the actions are happened. So here defining degree of freedom is important for the robotic structure, otherwise it is difficult to manage the overall motion. So the type of robot what you select it is also important. So whether you need such motion, whether you need a Cartesian robot or a polar robot or a articulated robot or a different specific application robot, you are going to define based on the robotic structure. Even the cost also depends upon how accurately you need the work to happen for the robot, otherwise the cost of the robot it is be too much for the company. So based on the type of operation what you need in the company, that you are supposed to decide and go. Otherwise you cannot go with the specific need of the work. So like this, the not only the type of robot, so there are different parameters based on the type of system, like hydraulic system, pneumatic system, what are the type of actuators you are going to use, what type of sensors you are going to use. All those things are defined clearly. So based on the defining of the parameter, here it is defined. So here you can also see rolling is present in one direction, yawing is present in one direction, pitching is present in another direction. So all these parameters has to be defined while selecting the robot based on the type of motion, based on the manipulator, based on the end effector, what tool you want to attach. Based on that, overall things are defined at the workplace. If it is not defined properly, then you cannot select the right type of robot for further process. So here sometimes you need linear motion also. In all the cases here you see all the cases it needs a rotational motion. Sometimes you need a linear motion also, then you have to select the Cartesian robot where we can have only linear motion. So in the Cartesian robot only we can do minimum motions. The two it will be linear and up to some distance. So if it has to be moved in the rotational or the other directions, it is not possible.